Well, hey there, grill enthusiasts. Welcome to the Metrology Learning Network, where we explore the fascinating world of measurements and calibration and apply it to everyday life. I'm Ryan with Sign Calibration School, and today we're diving into a hot topic, barbecue probes. Whether you're a weekend warrior or a seasoned pitmaster, you've probably used one of these handy gadgets to check if your meat is cooked just right. But have you ever wondered how accurate these barbecue probes are really? In this video, we'll put some popular barbecue probes to test and see if they measure up to their claims. We'll compare their readings against our professional grade equipment used in calibration labs. Now, spoiler alert, the results may surprise you. By the end of this video, you'll know if you can trust your probe or if it's time for an upgrade. So let's get started. Now, I got a whole bunch of different brands and with different accuracy claims, and some of them with no accuracy claims. So how accurate are they really? And all of them are different brands, except for you're going to notice we have two Taylors. Now, this one we've had in the family, like we bought this from Walmart maybe 10 plus years ago. And so we're going to have one old one that someone could buy at a store. This was from Walmart. And then the rest of these. And to include two that are app-based. This one is a full wireless probe, and this one is a Bluetooth probe, but it has a wired thermometer on there. So I think the first thing that we should do is talk about the players today. And so let's take a look at those real quick. As mentioned, we have a second Taylor here. Now, if I would have thought this through, I wouldn't have had one that was top facing. But unfortunately, this one is, so you're going to see some pictures inserted of the measurements when we're talking about it. This one goes up to 450, but because of our Yumly here, our wireless probe, it only goes up to 210 degrees Celsius. So, 210 degrees Fahrenheit. And so that's the highest we're going to test for this is going to be 200 degrees, which is perfect for things like brisket or some of the roasts that you cook in the oven. And what's interesting is this one's actually sold on Grainger. So this could be something that you could get through your supply in some industry work situations. Next, we have the PT09 from Lavatools. I actually bought both of those, this Taylor and this Lavatools off of Amazon, but you can buy it here on their website as well. Here, performance, the accuracy, 0.9 degrees Fahrenheit. And actually the reason I chose this one is on Amazon is listed as a commercial food thermometer. So I figured many people going on to find a really good thermometer might say, hey, this is a commercial one. That means it's better, right? So far we see that it's just a little bit more accurate, 0.1 degree Fahrenheit more accurate than our 1 degree over here from the Taylor. So we will find out if that matters. Next, we have ThermoPro. There are a lot of ThermoPro products out there. This is just the one that we happen to pick. This one says instant read. We do not like that statement at all in temperature. Temperature is not an instant read situation. People, temperature is not instant read. Temperature is not instant read. You can have things that have a fast refresh rate, but not instant read. So just one of my pet peeves there. This one's also a 0.9 degrees Fahrenheit. And again, we're not going to go anywhere near that 572, but just so you know the top end of that one. Our students asked us to test this, the Typhur, because it is an InstaProbe, which again, no such thing as an InstaProbe. Our students noticed this, NIST certified, which is for all of the metrologists watching, but those of you that don't know, that's a no-no statement. I guarantee NIST does not certify this measurement or anything to do with this company. They just don't do that stuff. And they have statements on their websites and stuff like that. So it's interesting that they put NIST certified on here, but it also, look at this, 0.5 degrees Fahrenheit. So is that true? So we will be able to test that. And just so you know, we have made it so that all of these have the best testing scenario possible. So as you'll notice, these have a specific diameter. We're using holes in our dry well that fit the probes perfectly on all of them. So they're all getting their best chance to hit their temperature marks. And also, I like that it mentioned that it is a direct contact thermocouple and full readings in 0.5 seconds or less. Again, to hit their accuracy specs, I'm going to tell you right now that's incorrect. It's just not possible. And then we have the iGrill Mini. Picked this up at Lowe's. This is it's a Weber, right? So going to be very popular with people. They'll just see the brand. But what's weird is that I did not find any accuracy specs. I even went into their manual. I found its general top end, don't go above the 572, similar to other ones. But I didn't find any other information. So if any of you can find it, I'm not saying I'm perfect. I just couldn't find it. And then we have the Yumli. That's this wireless one. Picked this up at Lowe's. Now this one has a maximum ambient temperature. So the handle, this little black part that sticks out of your roast, you want the whole probe to stick into a roast is how they tell you to use it. So this handle has this higher temperature range, which makes sense because that's going to be exposed, right? So that has that same as most of these other probes. But that internal one, only 210. So there is some limitation there. I don't think you're going to find too many cooking situations that go above that. Like I said, when I do brisket, you're starting to check for tenderness at around 200. So I don't see any problems with that temperature range, but I thought I would mention it. And again, I apologize, Yumli, if you have the accuracy spec somewhere, I just couldn't find them. I did find this post about inaccurate results, and they tell you they ask you to set up a water and ice bath, and then it should drop to 32 to 36 degrees, which is a 4-degree window. We're supposed to be getting 32 on that. I don't know. So if anyone knows, or if anyone finds that, please let me know. So in calibration, those are the device under test, or DUT, or sometimes it's called the UUT, or unit under test, or the TI, the test instrument. So that's our unknown, but we also need our standard, which is our known, or something that's traceable. So today we'll be using our temperature standard, which we have a thermometer readout here, which is an Additel 282. Additel has been very kind to us at the school. They give us discounts, but we're not sponsored by them or anything like that. So everything that we state here is not sponsored in any way. But a really good products. I enjoy using their stuff. So we're going to have this readout with this AccuMac 1751 secondary reference platinum resistance thermometer. That's what this PRT means. Platinum resistance thermometer. And if you see just this probe alone, accuracy is less than 0.012 degrees Celsius at the triple point. That's what 0.01 degrees Celsius is the triple point. More to come on that in a different video if you're lost. But just know this is an extremely accurate device. So all the way through its range, you notice that the first digit after the decimal point is all zeros. So when we're comparing them, and you're thinking of our probe compared to one of these that we're testing, realize that the resolution of all of these temperature probes is 1 digit past the decimal point, where our probe is definitely accurate to that digit. Like, we can trust our probe completely. So a very good comparison here, and we will know whether or not their accuracy claims are true. And yes, all of our measurements are traceable. We're not accredited. We're not an accredited lab, but we are. All of our measurements are traceable through NIST to the SI, which is the proper thing to say, not NIST certified. Last but not least, we will also be using what's called a dry well. So if you see over here, these are dry wells. Now, they are a source of temperature. So I can put in a temperature, it will climb to that temperature, it will hold that temperature in a stable fashion, because we just want a temperature around there. Now, granted, some of these can be calibrated. In fact, ours are. So they do pass calibration and they are accurate in themselves, but they are not accurate enough to calibrate all of these probes. Our probe is. So when you see a temperature on one of these, and for instance, we will use 875 because we had that set up for filming, but we also use the 878 on the back wall. We basically ignore this readout, even though it will look like it's perfect. It will be holding a temperature, but we will be referencing our probe and our readout from our reference thermometer. So something I do not want to miss here is when we're talking about these dry wells, and I say, hey, I give all of these temperature probes the best chance possible. I'm talking about because of these inserts, and you see all of these have different size holes, and it just so happens that like the Typhur fits perfectly in this very small one here in the middle, where it has perfect thermal contact for these tests, where some of these others like the Yumli fit perfectly in these 1/4 size holes. So just so you know, that's what these inserts look like inside of the dry wells, and what I mean by they fit perfectly for all of these tests. We made sure that they fit correctly for the test. And just to go over the temperature points in reference to time, we're going to be calibrating them all at 200 degrees, 165, so that poultry top end, 145, so pork, and then the 0, our ice point. If you didn't know, ice point is an extremely important thing for industrial probes, so we want to test them all at the ice point. There's calculations that go on inside of your probes. If the 0 is off, then most likely your other measurements are off. And in fact, those that do allow calibrations out of these probes, like the ThermoPro, you do that at the ice point, as we saw in that other manual as well. So those are the points that we're going to be testing. Please let me know if you have any questions, and let's move on to the tests. So what are our final impressions here? Now with this channel, I don't intend to go off and just dog companies to dog companies, right? So more than anything, I want to provide the data, kind of show you how we would test things, get you interested in measurements, but then also allow you to make some of your own conclusions from everything. I will say, like for cooking, if you have some of these that the have a faster refresh rate, it's just better for measurements if you're sitting there trying to measure something, especially with just the tip. I mean, if we put any of these in here, even the Typhur, which I think was by far and away, it was super accurate. Again, it just is making interesting claims that I don't think they should. But when it comes down to it, do you need something that accurate? And that brings in to the Yummly and the Weber, where those are very clearly, to me, designed for roasts and things that, if it's within, because they don't even have a decimal point of accuracy, you know, they're all full temperature. And so it's like, hey, is it about time for me to start checking what I'm cooking, you know? So when it comes down to it, the old Taylor, I think we can all say, still doing good, even though we've replaced this in our own house, but like, hey, still hanging in very well. So when it comes down to it, if you're doing the tip type measurements, you're going to be at least 2 degrees off. The most that we saw degree off wise was 6 degrees with tip measurements on these. So a huge possible differential there. But that refresh speed, that's all it is when they say instant read or something super fast or measurement ready in anything that's under a minute. I mean, we none of these devices were at a stable temperature and ready at their best accuracy in less than a minute. And that's just honest testing here. So take that for what it is. I hope you enjoyed the video. If you have any questions, please let us know. If you have any suggestions, please let us know. And thanks for watching.